Hey, this is Norm with Quantum Innovations, and I'm going to talk to you a little bit about refractive index. The first thing that I want to talk to you about is a basic formula of regarding light and light in a vacuum, and that is, and I may have done this before for everybody, T plus R plus A plus S equals 1. So this is transmission, reflection, absorption, scatter equals 1. That's 100% of the light. One of the phenomena, and you can look this up, maybe Wikipedia or something like that. I've also got several blog posts that talk about total light or light in a vacuum. So one of the things I want to talk about today is refractive index, because everything that's on the earth, and when we're talking about lenses in particular, all the different things that make up the lens have refractive index. So you have the lens, you have the hard coat, you have the AR coating, you have all the components of the AR coating. All those things have different refractive index. Well, what is refractive index? And I've got an image for you in a second, but the first thing I want to do is I want to draw an image. And again, you can look at our other blog post, a written blog post, AR coating, are we looking at this wrong? And you'll see an image of this that will look a lot better than what I'm about to draw. But as light comes in and hits a surface, it does several different things. So it's going to reflect and it's going to refract. Well, the angle of the refraction and the angle of the light that hits the surface is there's all this computational math that goes in to figuring out all of these things relative to all of the components that we're dealing with. So now the refractive index of a material, and most materials are known. Now we can take those refractive index numbers and calculate out all of our calculations to figure out how to make an AR coating, how to make a mirror coating, and to understand some things that we're going to talk about in another blog post, things like birefringence and stuff like that. I wanted to show, and you can look at this, I don't know if you could see this, Dale, but this is an image of light going through a piece of plastic. And this is an image of refraction. So as the light goes into the surface, this is the incident angle, then it's bent, then it goes out and it's bent again. That angle is the refractive index, the index of refraction of light as it passes through a material. So knowing this information is very important for us when we're calculating all the things that we're doing. So again, I'm not going to go into the math behind refractive index. The important thing for us to know is that it is, and understand what that number is and how it affects everything that we're doing when we're making AR coatings and we're making mirror coatings and putting hard coats on lenses, and understanding that when we say that it's a 160 index, that's the refractive index. So that's how it's going to refract light. When we look at materials like SiO2, ZrO2, and we ion assist materials, well, when those things all have an effect on the material's refractive index. So if we ion assist a material, we can increase or decrease the refractive index. So zirconium, for instance, may have a refractive index of 1.92 to 2.1. But if we use an ion source in that material, we can affect that refractive index and change it, and that has an effect on our coating, and all that has to be understood for what we're doing. Take an opportunity to look at Wikipedia or something like that to get some more in-depth information, or look at our previous blog posts on refractive index.